Hello and welcome to another free code session. My name is Jason Bach, and the first thing I think we're going to have to do is prevent people from passing in a type that has any static abstract members on it. I tried to run the first set of types I'm calling core.NET types for .NET 7, and there's just so many that are coming through now that have to do with, I believe, the fact that I'm letting interfaces that have static abstract members come through. So what I'm going to do here is let's create a couple tests first. When interface has static abstract method. Okay, so we're going to do one and then we're going to do the other. Okay. Now, why is this called? Oh, that's the type. Okay. Target type name. I have static abstract method. Good enough for me. Sorry, I want to do this. Just because. I mean, why not? Is it that? I think that's it. So here we'd want to say this and this, and then we get rid of those. And then we say static abstract foo. Okay. Now. Oh, there's 4 up there. Okay. It's like that should close off, and yeah, it does. Okay. Why is it the other way around? Oh yeah. You got to do this. That's my mistake. There we go. Okay. String must start with a quote character. That ain't it either. What am I doing wrong here? Okay, what is this barking at? Raw string delimiter must be on its own line. And it is. Hold on. One moment, please. Because I've done this for my C# 11 talk. So I have an example. So yeah, blah, 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 blah. Oh, you don't put it on the, okay. I was being stupid. You just do that. And there you go. Okay. Anyway. So what we're going to want is well, first of all, we want this to fail. We want this to fail for both reasons. I want it to think that type to mock is null, and it's not going to be null. It's going to say, yep, I can mock it. So why did it fail? Well, it did have, interesting. It does have one. The type I have static abstract members has no members that can be overridden. Okay. Oh, was that why? Because it didn't actually have it returning a type. Then I just wasn't thinking at all whatsoever. Yeah, now there's 0. And type to mock is probably something. Okay. Okay, so we're wrong on both counts. And that's exactly what we want. Okay. So what we want to do is come up with a diagnostic. 1, 2, 3, 4. Yeah, we just have 4. 5, 6. We want to have type has, well, we'll call it interface has static abstract members. Diagnostic. Okay. And this one will be that, and that, and that, 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 and that. Okay. And I think I had 1, 2, 3, 4. This will be 7. Okay. The type blah has static abstract members and cannot be mocked. Type interface has static abstract members. Okay. And then we also want to go to the docs before we forget, because It's always good to have docs. If an interface has any static abstract members, it cannot be mocked. And I'd like to reference the error. Well, by the time I did this, there. Okay, so I just talked about this. Hold on. Yes, that's the one I wanted. Okay. There. Okay, I just want to make sure I have that there. Okay, so now we have the thing here, but now we need to go into mock information. And somewhere down here, we're going to need to any, but doesn't matter. If type to mock get members where any is static, when we abstract we don't want it virtual. We want it to be, yeah, static. I thought I saw that there. It's like, why wouldn't you have that there? So if it has any of these, interface has static abstract members. Okay. And I think I would, I'm thinking in the future when I get to that point of, if you get to like something like this, you would only do these if you haven't had any diagnostics yet, because there's no point in trying to do any more work. If you've gotten to this point, you think you can't mock it, but that's for a different day. Okay. So now this should be interface has that, and it should be null. Now there will be the compiler error itself that won't let you pass that in as a generic, but we want to stop us and say, no, we know you can't do that. So there we go. And I'm just going to run all the tests just to make sure. Good. All right. So I like this now. They have the, it follows the pound thing. It didn't have that little drop down there, which is nice. Okay. I'm going to stick with Sams and Sammies. I don't care. I'm not going to keep saying that big phrase all the time. All right. Now we can go back to the program here and we'll close all but this. So now we'll be able to see hopefully a lot less errors. So let me run this and see what happens. We'll still have some, I believe, but not like I saw off camera, which was just this massively scrolling list of a whole bunch of stuff. So yeah, this is still some of them. Yeah, this isn't good because I'm seeing I-binary floating point. That shouldn't be allowed. So we see less though with the mocks. You notice that? I know it's a lot to see here. Does not implement static interface member. Yeah, you shouldn't be. I don't understand why it's thinking that there is. So I unsigned number of. Let's look at that one. Oh, that's right. It'd be defines a number type that can only represent positive values. the type that implements the interface. Yeah, it's this kind of weird, fun thing that they do with interfaces now. So what happens when I go to the definition of it? All it needs to be is something that implements it. So this is going to be a weird trick because you can't do object. That doesn't work. If I say int, does that? I'm doing it outside of an area that makes no sense. Okay. And it'd be int. There, okay. So that works. And I get why, because unsigned int implements unsigned number. But if this comes up in the future, like right now I'm just guessing, I'm saying when I generate this, I think there's a part to say code. Yeah, create or make. But there's something in here that says, yeah, I'm like, if it does this, then just pick an int. If it has a reference type constraint, then pick object, otherwise just go with object. So, and I even have up here, this isn't complete. I know it's not complete. So I think one of them is going to be this weird case where is the constraint of itself. And that one's going to be a fun one. So I'm actually going to do this. We're going to, well, let's keep this up because I want to remember which one I'm looking at. I could make here a public class thing that implements I unsigned number of thing, right? Now, of course, it's going to say you need to implement it, right? If we just say implement it, then this should be okay. Let's just do remaining members explicitly. And then this is now just, it's down to these two. But that's okay, I can do that, okay? And again, if I go to the definition of this, this is just saying T-self has to be, if the type I'm given, oh man, this is going to be a, if the type I've been given has a constraint that says it has to be of a specific type, yeah, I think that's more the way to look at it, sort of. Like say, for example, I had, let's get rid of this. Like say I had public interface, interface I x of t, where t must be, I don't say a string. Let's say it's a public abstract class thing. We don't know what it is just yet, but it's got to be a thing. Okay. So this is saying, yeah, I know on namespace, whatever, but this is saying, okay, well, the t, I couldn't pass in a type of object to it, for example, because that wouldn't make any sense. But now I have to be smarter to say, well, okay, what happens if the constraint is of a specific type? What I would potentially have to do then in that case is generate something. Like, where did I do that? Here. I'd have to get the type definition. But while I do that, I would also have to give an option to say, you also need to generate a type for this test of this value. And it could be a meaningless type name. I mean, it doesn't matter what it is. I mean, it could be a GUID as long as it starts with a letter. I think it could be anything you want. But that would then say it satisfies that constraint. Now, if it's of a type, that means that it has to, well, does it? Because if I said here, like where it's a string, yeah, that doesn't work because string is sealed. So you can't, and if it's of another type parameter, like if I said TQ, where T is of type Q, well, that's okay. That's saying that if I pass this in here, whatever I pass in as Q, T must be of that type. This is going to start to get, I've totally ignored this. I've completely ignored this and said, well, what happens if this type has I don't even know what I'm doing here. When I say test generator, I'm saying get type definition. That's this. So I say self full name, split that off, and then I put in generic arguments, which for each one, I put in a value here. Otherwise, if it's just it was an interface, I have A and had no generics, then I just return the name of it, and that's fine. So I think I'm going to do another episode here where I have to think about this for a while. And again, I don't want to do all that work on camera, but I know at least a problem that I definitely have to solve, which is given a generic type definition, how do I figure out what that type can be? It's if it's a self type, if it's a, this will be definitely a problem to mull over this afternoon. So I don't even know if I'm going to be able to record another episode today because I think this is going to take some time to get my head around, but that's what it takes. So we shall see. Next episode, hopefully I'll have this method updated to basically say, here's the type definition, and also here are all the other types you have to define if needed to make this work. Thank you all for watching. Leave comments and questions below. See you in the next episode.